In the first part of this example problem, we have a truck pulling on a log. We're given that the mass of the log is 300.0 kilograms. We know that the coefficient of static friction between the log and the ground is 0.74, and the coefficient of kinetic friction is 0.45. And the question is, with what force must the truck pull in order to move the log? Well, to analyze any problem like this, we first have to think of all of the forces involved. They're drawn out for you already on the diagram, but I want you to think about them. First, we have the force with which the truck is pulling. Fighting that force is the force due to friction, so we draw an arrow that's opposite the force of the truck. Those are the only forces in the horizontal dimension. But there are two forces in the vertical dimension. The weight of the log is pulling straight down, and in response to that, the ground is pushing back with a normal force that we'll label Fn. Okay, those are all the forces in the problem. Now let's concentrate on the horizontal dimension because that's where the action is. We're trying to get the log to move in the horizontal dimension. Well, if the log is going to move in that dimension, then the force with which the truck is pulling, capital F, has to be at least as large as the frictional force, little f. So if we figure out the frictional force, we'll figure out the force with which the truck must pull. What's the frictional force? Well, we have an equation. The frictional force is mu times the normal force. Now in this problem we're given two mu's. Which one do we use? Well, the log is sitting still. When things are sitting still, we use the coefficient of static friction, mu s. Well, the only other thing we need to know is the normal force. What's the normal force? Well, to figure that out, we have to look in the vertical dimension. Remember, weight's pulling the log down, but the ground is pushing back up on the log so that it doesn't accelerate downwards. So the normal force must counteract the weight. In other words, the magnitude of the normal force has to equal the magnitude of the weight. Well, we know how to calculate weight. Weight is simply mass times g. We know that the mass is 300 kilograms, and we know that g is 9.8 meters per second squared. So the weight is 2.9 times 10 to the 3 kilogram meters per second squared, or 2.9 times 10 to the 3 newtons. Well, we can take that weight and stick it into the equation that says F normal equals weight, and we know that F normal is 2.9 times 10 to the 3 newtons. Well, now that we know mu and F normal, we can calculate the frictional force. Mu is 0.74, F normal is 2.9 times 10 to the 3 newtons, so the frictional force is 2.1 times 10 to the 3 newtons. Now what does that tell us? Well, remember, in the horizontal dimension there are only two forces acting. The force with which the truck is pulling, capital F, and friction, which we just figured out. In order for the log to move, the force with which the truck is moving has to at least equal the frictional force, so F must be at least 2.1 times 10 to the 3 newtons. So look at how we solved this problem. There are four forces in the problem, and we had to figure out three of them in order to get the last one. In order to get capital F, we needed to figure out little f. But little f depends on F normal. So we had to figure out the weight so that we could get the normal force. That gave us friction. And now that we had friction, we know that the force with which the truck pulls has to be at least that great. This is the kind of reasoning you have to be able to do to solve these problems.